Hello people, welcome back to my programming series. Today I'm going to talk about generic programming, and we're going to cover what does the word generic mean, what is generic programming and why do we use it. We're going to take a look at some analogies with English language about the levels of how generic something can be, and we're going to talk about what does it mean to be generic, how should we think about it. So let's start off with the definition of generic. So the dictionary says that generic is an adjective, and it means having no particularly distinctive quality or application. So let's keep that in mind for the future, that there's no particularly distinctive quality or application. So in programming, what do we mean by generic? We usually mean that in generic programming, we usually mean that our type system is dynamic, so that when we write a function, it doesn't matter what we pass in, what comes out. Or maybe in a strongly typed language, we have some sort of template system where we can kind of get around our type system by saying we want the type of our data structure or function or class can be of any type, or we can determine a type later on. So why do we do this? Essentially, the idea behind generic programming is the don't repeat yourself principle. And because if we don't have a way to say that, say, a vector can be an integer or a float, then we would have to write an implementation for vector for each type that we would have. We'd have to write an implementation for vector with ints and floats and every type of struct that we could ever think of. So instead of writing a million different implementations of vector, we can write one implementation of vector and have it take in any type of data structure. And that allows us to not repeat ourselves. That hopefully allows us to have shorter code that's more readable and easier to maintain. And so that's the kind of the programming idea of generic, of using templates or a dynamic language. So let's take a look, though, at what generic means in, say, using the English language. So in the English language, we have primitives like letters, and then we can combine those letters to make phonemes or sounds. And then we can use those phonemes to create words. We combine them together to create words like dolphin, hat, and propeller. And what we do is we memorize these words, and we have conversations using these words that we've memorized. What we don't do is we don't memorize millions and millions of sentences and then have conversations with people by picking out a sentence that we've learned years ago. What we do is we talk extemporaneously. We put together words on the fly to create sentences and paragraphs and whole conversations. So what this tells us is that there's kind of a limit to how general we can be. Words are pretty general, which means that you can memorize them and then pull them out when you need them, use them. Sentences aren't very general. They're very specific. They normally have very specific things that they're trying to accomplish. So we don't memorize sentences or paragraphs. We memorize words. But even among themselves, words have different levels of genericity. So as an example, the phrase "over there" can be used in many contexts, and it doesn't matter what you are. If you're a biologist, you can talk about your experiment that's over there. If you're a physicist, you can say, hey, we need to move that magnet over there to get it away from my experiment. If you're a teacher or a mathematician, or just anyone in normal day conversation, can use the words "over there." So the phrase "over there" is very general. By contrast, tympanic membrane is not general, right? It's used in very specific instances and very specific contexts, usually in a medical context. So you don't normally hear chemists going around talking about the tympanic membrane. And this gives us kind of a key to how to think about genericism. there wasn't any special conjugation or anything that we did to the words over there to make it generic. And there's nothing special that we did to the tympanic membrane to make it specific. What determines its genericness or genericity is its usage or its applicability. So let's take a look at that. So what does it mean to be generic? So genericism is determined by wide applicability, not implementation. So just like with the English language, there was nothing that we did specifically to the words over there to make it more widely applicable. It was actually its applicability that made it generic. So by this token, we can say that you don't make something generic. Something is generic. You have to discover its level of genericity. So for example, big nums and HTTP. Big nums can be used in many different contexts, exactly how they are. So they can be used in cryptography, in scientific applications, modeling and simulation, normal math. They can be used exactly as they are in many different contexts. So a big num or a big num library can be written and used in many different programs without any change to itself. That is generic. The same goes for HTTP. There are HTTP libraries out there for many different languages, and the reason why we have libraries for HTTP is because you can create millions of different applications, millions of different web services that use the same HTTP library. So the HTTP library has wide applicability. You don't need to change it at all, but it can be used in many different contexts. Right? A bad example of being generic is SOAP. I believe it stands for Simple Object Access Protocol. And this was used for creating web services. And the designers decided to make SOAP able to be used across any different transport protocol, any one that might be invented in the future. But it turns out people only used it with HTTP. And so there was a whole bunch of architecture and design that was put into SOAP that was completely unnecessary. It made the implementation larger. It made it more difficult to debug and change. It was more difficult for developers to understand, and it was more difficult to create. You wouldn't want to create microservices in SOAP. And so that was an example of designers trying to make something generic. Instead of trying to discover the level of genericity that something had naturally, they tried to force a level of genericity on something. And so those are the points down here. Trying to make something generic creates bad design. So what can we take away from this? Well, what we need to do is learn that, or come from a perspective where trying to figure out how generic something is a discovery process. It's not something that you impose on your code. It also means that having a template does not mean something is generic, right? We're kind of defining two different uses of the word generic, just like there are different uses for the word love, right? In this context, we're talking about generic in that something can be used as it is without any change to itself, any change to its implementation. So in this sense, integers are generic. They can be used without any change to the implementation of integer, and they can be used in many different applications. They have wide applicability. So integers are generic. Arrays are generic. And you can take this even from your data structures and functions all the way to your architecture and design, right? Maybe there is a certain architecture of something that can be used without any change to itself across many different applications. Now another thing that we need to learn from this is what we learned from the English language, that there's only so many, the number of generic things is actually quite small compared to the things that are not generic. So the number of words that we learn to speak the English language is relatively small compared to the number of possible sentences and paragraphs that we can put together. So when we write applications, we need to keep in mind that a lot of the code that we write is not going to be reusable, right? And it shouldn't be reusable. It has a specific purpose. So these are the things to keep in mind. And that's all I had to say for this time. Thank you for watching. Till next time.